Hi and welcome. In this tutorial, we'll explore the types of constructors that are available in C# and how we can implement each type of constructor through code examples. So, what is a constructor? Let's look at a quote from the Microsoft Docs. Whenever a class or struct is created, its constructor is called. A class or struct may have multiple constructors that take different arguments. Constructors enable the programmer to set default values, limit instantiation, and write code that is flexible and easy to read. Let's click on this link marked as using constructors. When a class or struct is created, its constructor is called. Constructors have the same name as the class or struct, and they usually initialize the data members of the new object. In the following example, a class named Taxi is defined by using a simple constructor. This class is then instantiated with the new operator. The Taxi constructor is invoked by the new operator immediately after memory is allocated for the new object. For content like this and much more, please consider subscribing and please ring the bell to be notified of future content. If you like this video at any point, please give this video a thumbs up. It will be greatly appreciated. Right, let's look at a brief overview of the types of constructors that are available in C#. Then we'll look at some code examples to implement the various types of constructors. Default constructor. A default constructor is a public parameterless constructor that is provided automatically if the developer has not included a constructor within the relevant class or struct. This is an instance constructor because this constructor is invoked when an object instance is created from, for example, the class in which the constructor resides. Parameterless constructor. This constructor is implemented by the developer and does not contain any parameters in the definition of the relevant constructor. This is also an instance constructor. Parameterized constructor. This constructor is a constructor that contains one or more parameters in the definition of the relevant constructor. This is also an instance constructor. Static constructor. This constructor is typically implemented by the developer for a class that contains static members. This constructor can only be run once during the life of the application in which it resides. So the static constructor serves as a good place to initialize static members. This constructor is not an instance constructor. Private constructor. Like the static constructor, this constructor is also typically implemented by the developer for a class that contains static members. It prevents the developer from implementing calling client code that is external to the class in which the private constructor resides from creating an instance of an object derived from a class that contains the private constructor. So calling client code external to the class in which the private constructor resides cannot use the new keyword to create an object instance from the relevant class that contains a private constructor. The following is a brief overview on private constructors from the Microsoft Docs. Private constructors are used to prevent creating instances of a class when there are no instance fields or methods, such as the math class, or when a method is called to obtain an instance of a class. If all the methods in the class are static, consider making the complete class static. Copy constructors. Copy constructors are implemented to facilitate the copying of an object at runtime. So, if for example the developer wishes to implement code that creates a duplicate object of a particular object at runtime, a class with appropriate copy constructors can be used for this purpose. This will be clarified later in this tutorial through a code example. So, let's look at code examples to gain a better understanding of these constructors. Let's first look at what is meant by a default constructor. Let's create a public class named Rectangle. I have deliberately made these examples really simple so that we can understand the coding principles behind these constructors. Let's create two public fields within the Rectangle class and initialize these fields with values. Width as int equals to 20, height as int equals to 10. Let's create a local constant named shapeName and assign it with a text value of rectangle. Please note that I am using fields here for the sake of this example, but in a real-world application, it is always better to use properties instead of fields. This is because using public fields like this allows any method anywhere in a program unrestricted and unverified access to an object's inner workings. Data members should generally be private and should be accessed only through class methods and properties. Let's create a public method named draw. In the interests of time, let's just write code to output status text to the console screen rather than actually draw a rectangle. If you are interested in code that outputs shapes to the console screen, code for drawing shapes was provided in 2 tutorials provided by this channel, one on structs and the other on the object-oriented principle of polymorphism. Links to these tutorials are available below in the description. So let's go to the main method, and you can see, even though we have not included a constructor within the rectangle class, we can still use the new operator to instantiate an object derived from the rectangle class. This is because if we don't include a constructor in, for example, a class, a default constructor is automatically provided for the relevant class. Great! So let's go back to the rectangle class and remove the code that initializes values for the width and height fields. Let's include a parameterless constructor and let's initialize the width and height fields with values within the parameterless constructor. Great! So, if we want the developer of the calling client code to be able to pass in width and height values when creating an object instance derived from the rectangle class, we can simply include a parameterized constructor like this. Note that we can overload the parameterless constructor, meaning we can include more than one constructor within the same class. To overload an existing constructor, we need to ensure that each constructor contains a different parameter list. A constructor's parameter list can be distinguished from another constructor's parameter list by including parameters of varying types when compared to the types of the parameters in the other constructor or constructors. A constructor's parameter list can also be distinguished from another constructor's parameter list by ensuring that each constructor has a different number of parameters. If you have 2 or more constructors within, for example, a class with exactly the same parameter list in terms of data types and number of parameters, a compile time error will be flagged. Great! We can also write this exact same code in a different way by using the this keyword, like this. Great! So we have covered default constructors, parameterless constructors, and parameterized constructors. Let's look at an example where we might use a private constructor. So let's create a class named shapes. Let's create 2 static integer fields, width and height. Let's create a public static method named drawRectangle that has no parameters. Let's create an overload for the drawRectangle method that contains a width and height parameter. Let's create a private static method named outputRectangleDetails that can be used by our drawRectangle overloaded methods. Now let's create a private constructor. Let's go to the main method and perform a quick test. We have just demonstrated the correct way to consume our shapes class. If we tried to create an instance from our shapes class like this, a compile time error is flagged. This is because by including a private constructor within a class, this means the class cannot be instantiated in this way by calling code. Let's now look at an example using a static constructor. Let's comment out our private constructor code and write code to include a static constructor in our shapes class. A static constructor must not contain an access modifier and must be parameterless. Let's create a constant named datetime format like this. Let's create a private static read-only string member variable named timestamp. Within our static constructor, let's set the timestamp member variable to the current date and time, and use our datetime format constant to ensure that the data is outputted in the desired format. Let's introduce a bit of latency within our output rectangle details method by putting the main thread to sleep for 1200 milliseconds or 1.2 seconds. Then let's write code to output the date and time stored within our timestamp member variable that was captured in the static constructor next to the current date and time captured within the output rectangle details method. Let's run the code. You can see that each time the output rectangle details method is called, the date and time that was set in the static constructor has not changed, but the date and time captured and outputted within the output rectangle details method is different each time it is called. The static constructor is called only once during the life of the relevant application. The static constructor allows the developer to write code to initialize static members in the static constructor. I recommend reading more about static constructors at this location. Please navigate to the Remarks section on this Microsoft Docs webpage for more detailed information on static constructors. Let's move on to an example of implementing copy constructors. Let's create a class named rectangleCopy. Let's create a constructor that contains width and height parameters. Just a quick tip, you are able to generate template code for a constructor through Visual Studio by typing CTOR and then pressing the Tab key twice, like this. Let's include width and height public fields of type integer within our rectangleCopy class. Then let's include a constructor overload that contains a parameter of type rectangle. So you can see that we are going to use the rectangleCopy class to facilitate creating a copy of a rectangle object at runtime. Let's go to the main method and test how we can implement this copy functionality using our copy constructors. Great! So, we have now covered the types of constructors available to us in C#: default constructors, parameterless constructors, parameterized constructors, private constructors, static constructors, and copy constructors. As an added bonus, let's see how we might design our code if there was a requirement to add more shape classes to our application. So let's create a shape abstract class. Let's create a class named rectangle shape that inherits from the shape abstract class. Note how we use the base keyword to pass arguments passed to the rectangle shape constructor down to the base class, which is our shape abstract class. So let's create a class named circle shape that inherits from the shape abstract class. Let's write calling client code in our main method. Great! And if we wanted to facilitate copy functionality so that calling client code can create a copy of an object of type rectangle shape at runtime, we can create a class that contains appropriate copy constructors like this. Excellent. I hope you've enjoyed this tutorial on the types of constructors available in C#. For content like this and much more, please consider subscribing, and please ring the bell so that you'll be notified of future content. If you like this video, please give it a thumbs up. It will be greatly appreciated. Please feel free to share this video with anyone you feel may benefit from its content. I really enjoy reading your comments, so please feel free to engage with me in the comments section. The code created for this tutorial can be downloaded from Github. Please see the location of the relevant Github repository below in the description. Thank you and take care.